Hello, everyone. Okay, so I'm gonna record this session just in case if you're interested to have access to the recorded session, send me an email. Okay, so I will post my email address on the board. Okay, you can, when the recorded session is ready, I will send the recorded session by today or tomorrow. Good. So let me just share my screen. There you go. Okay, so we have these problems and there are multiple choice problem and also problem okay, so and which one do you think is better to start, because we have 1 hour and almost 20 minutes. Okay, so do you think it's better to start with the multiple choice problem or just the problems? Okay, so I can start with one problem, okay, and then come back to the multiple choice. Okay, to do 2 3 multiple choice and they again go to the problem, because sometimes problem takes more than, you know, couple of minutes, more than 10 minutes or 20 minutes. Okay, so okay, so and let me just go to the problems and I can start with problem number 1. Okay, let me just take a screenshot. Okay, so please let me know if I go a little fast. Okay, so I may ask you a couple of questions, ask you, okay, to see how you can go over this problem. Okay, if you couldn't, okay, we will try to go with each other. Problem 1. During the demonstration of the centripetal forces in action, I was whirling in a vertical loop in a vertical loop, a ping pong ball on a plate. The radius of the loop was 50 centimeter, and we assume that I can keep the speed constant. Good. What is the maximum speed at which the ball will stay on the plate at very top of the loop? Good. How many revolution per second does this speed represent? And how would the minimum speed change if the radius of the loop is double? Good. So I'll try to just draw the situation. So what exactly the situation look like? We have a plate, yes, good. And this plate is a vertical plate, good. So, and then which the plate has the radius of 50 centimeter. Let me just change the color. Okay. 50 centimeter, good. And it's telling that we have a ping pong ball on a vertical loop. So again, this is going to be the vertical loop, yes? And this ping pong ball is keep rotating around this vertical loop. Okay. What is the minimum speed at which the ball will stay on the plate at very top of the loop? At very top, it means that this ball can be anywhere on the loop. Okay, it can be here, it can be here, it can be here, but this question is asking me what should be the minimum velocity of this ball if it goes on the top, it's keep moving the circular motion. Okay, so this unit you uh, have learned how to identify forces, how to apply Newton's first law, second law, and third law, okay, to be able to solve this problem. Good. Okay. So on the top, I pick on the top. The ball when is on the top. Okay. Can you tell me how many forces are exerted on the ball? What are those two forces? Normal and weight. Okay. And can you tell me what are the direction of those two forces? Top. Which one is top? Which one is bottom? Okay. Weight is down. How about the normal?
Direction of the surface.
Okay. Normal is up. Both is down. How about you?
I'm still trying to write it down.
Oh, okay, good. So, what is the normal force? Normal force is the force which is exerted on object by the surface. Okay, so you're telling that there is a normal force, yes? Okay, normal force should be exerted by a surface. Where is this surface? On the top, yes? This is a plate. The plate has something as a surface, yes? And this ball is going, through this surface, yes? Good. So when the ball is here, this surface exerting force, yes, on the ball. What direction? Down. So here, here, this part is the surface, yes? And this surface is in contact with the ball. And the surface is exerting force on the ball. What direction is going to be? Downward. But if the ball was here, good. What is the surface? What is the normal force direction? Perfect, because the surface is exerting force on the ball upward. When it was here, what is the normal force direction? Toward to the center. Why toward to the center? Because
Like centrifugal force.
yes, because of the centripetal forces, and there is one more reason. Normal force is always perpendicular on the surface. Radius is always perpendicular on the perimeter of the circle, yes? Good. So it means that this normal force should be in the direction of the radius, in the straight line that is connecting the surface to the center, yes? So this normal force is in this direction, but toward to the center. Okay. So, but I'm just analyzing the motion here. Okay. So what are those two forces? Normal force and force of gravity, yes? Okay, I identify my forces, okay, and I need to draw free body diagram. In circular motion. In circular motion. Oh, my battery. battery.
Only if they're on the top. Like momentum. That's how you gotta.
Good. Okay. So here, okay, here I am supposed to write the Newton's second law for a circular motion. What is the Newton's second law for circular motion? Sigma F equal mass velocity square over r, yes? What are these forces? Forces toward center, yes? How many forces, it means that the positive direction is always toward to the center. So positive direction, yes, always toward center. Good. So tell me, if I am writing this Newton's second law, okay, how many forces I have here? And both forces are toward to the center. Both are going to be positive. So N positive plus mg positive, yes? Equal mass velocity square over r. And velocity square over r, it is a centrifugal acceleration, yes? Which is always toward to the center. So at this point, I can erase these vectors, yes? So before continuing this problem, okay, let's say I am writing the Newton's second law, yes, at this point. The force of gravity is downward, yes? How can I write the force of, mv squared over r here? N minus mg. Why? Because n is toward, mg is in the opposite direction of the center, yes? It's going to be n plus negative mg equal m velocity square over. So the top and the bottom would be different, okay? How we are writing the net force. Okay, now I'm just talking about the top. Okay, go back to the top. So it's going to be n plus mg equal m velocity square over. Yes.
So the reason we're not doing the sigma f x and y is because it's a circular motion.
Yes.
So
Again, circular motion is there is one direction in the circular motion. Direction toward to the center. You have forces, try to just write down those forces are toward to the center. Good? So can you go back to the question and see what is asking? What is the minimum speed? This minimum is really important. It means that if the velocity is a little bit less than this, the ball will fall. Doesn't go through the circular motion, yes? When the velocity is about the velocity of the minimum, we assume that this velocity is about the velocity of minimum, yes? So can we say that when this velocity is velocity of the minimum, yes, this n is gonna be almost zero, is about to zero, yes? Okay, it's not exactly zero, but it's about to zero, okay? So we can, if I want to find the V minimum, I should say this V is so close to the zero. Good? So I say this is zero, yes? And now mg equal m velocity minimum, yes? S squared over, how can I solve for V? Cancel both sides, cancel, and then multiply both sides by r, and take the square root. So the velocity will be, the velocity of minimum will be a square root of, do we have the r value? What is the r value here? Okay, r value is 0.5 meter. Perfect. And what is the r? 9.8. Okay. So
Yeah, on the top. This is the minimum speed, otherwise it was negative, it will fall. So a minimum speed, and we'll drive it as a grade. And it's back.
first and last time I use it. Any question about this? Can I add one more thing to this problem? Hmm? It is okay if I add one more thing into this problem. Because I want to make sure that you know how to identify forces toward to the center. Good. Okay. So we are done with part A. Okay. Did anyone calculate that part A? 2.2 meter per second. If the velocity is less than this, definitely it will fall. It doesn't go through the circle. Okay. So if this was here, and let's say 30 degree, yes? 30 degree from this side, yes? From this. And is asking you, okay, to calculate the minimum velocity, whatever. I'm supposed to identify forces, yes? How can I identify forces? Normal force, yes? Force of gravity. Good. Net force is equal mass time acceleration. Again, we are done with this problem, okay, with part A. I'm just asking you to calculate the minimum velocity when this ball is exactly at this location. 30 degree with respect to the vertical. Look. So normal force, these forces should be the forces toward to the center. N is already toward to the center. How about mg? Is down.
It's negative.
Is negative, but it's okay. You know, it is when you call negative. Okay, I call toward to the center positive, yes, away from the center negative. But I have a vector. It is not toward. It is not away. It is in mg direction. Yes, it is in the void.
The next one.
We need to find its component. Okay, let's say I call this x-axis, yes, good, and I call this y-axis, yes. Can I do that? You know, again, you can place the coordinate system wherever you want, in any direction. I place the origin exactly the ball is, good? Okay, so right now, x direction is gonna be the forces that I'm calculating them, yes? N is already in the x direction. But how about the mg? Mg is not in x direction, is not in y direction, but I can find its component. Okay, good. So tell me, let me just change the color. Okay, so if this is 30, this is going to be 30, yes? So let me just change this. This is going to be 30, good. So this is 30, this is 30. Any question why this is 30? Perfect. Adjacent is always cosine, the other one is always sine. Okay, if I have mg, you know, this is going to be what? mg cosine 30, yes? What is the other one? mg sine 30. There you go. So I'm supposed to write these forces, yes? How many forces I have right now? Two forces, n and mg cosine theta. One is positive, the other one is negative, yes? I write this, I write positive n plus negative mg cosine 30, and this was v squared over I, yes? mv squared over r.
How come you swapped out the acceleration for v squared over?
Acceleration in the centrifugal motion is always velocity squared over r. Always. Okay, because we're still using the sigma f equal ma. When it is a circular motion, okay, acceleration is going to be the velocity square over.
But if it wasn't in circular motion, then it would just be
Just acceleration, normal acceleration, x-axis or y direction. Okay, then we will solve a couple of problems about it. So okay, so right now, like last problem, minimum velocity. Minimum velocity, it means that if I want to find the minimum velocity, I say that this is almost zero, yes? Good. So, and then, okay, I'll just, cancel, good. Okay, and then do the rest, yes? So I just wanted to show you how, we can just play with this, good? Okay.
What does M in this do again?
Mass.
Okay, that's what I thought. So you write mg.
mg, it means that, yes.
Your gravity,
Big.
then it's
Yes.
mass times.
Exactly. This is going to be FG. FG is the mg. Okay. So let's move on. Okay. I just wanted to I opened the parentheses to say that if the ball is somewhere else, okay, you need to identify forces, find the forces in the direction of the center, okay, and then go from there. Okay. So how many, okay, we just calculated the V, yes? V is 2.2 meter per second. And how many revolution it is this? Wh- How we can say, okay, but with this velocity, how many times it revolved, yes? Complete the circle. 2 pi? Okay, one revolution, yes, is 2 pi radian, yes? Good. One revolution is 2 pi radian. Okay. So, and what is the velocity formula? Is r omega, yes?
So we use linear, that's 2 pi r f.
I know. Oh, you don't use omega for now? Okay.
Yeah, then I go there.
But you haven't touched the angular velocity?
No.
No?
So no.
Okay. Just the linear velocity? Okay. So let me just. So, okay. From here, V is going to be 2 pi r over t, yes? So t is going to be 2 pi r over v, yes? From here, 2 pi time r was 0.5, yes? Divided by, what was the velocity? 2.2 second. This is the traveling time, okay? Traveling time. Good. So when you calculate the time, how much you,
0.4,
1.4?
3. 1.43, but isn't that seconds?
Second, yes. This is the time that it does say, okay, it start from the, rest, okay, and then keep moving. Okay, we don't know how many time, okay, how many revolution, okay, so, but
Isn't that 1 over t, 1 over?
1 over t, yes.
So the time for this equation is
Yeah.
always equal to the amount of time it takes for one full rotation.
Exactly. Okay. So, and then right now, if you want to, I'm just trying to, because it's asking how many revolution. Okay. So
Can we do this one more? Half frequency, and with, switch half with velocity, lose. Really need to find it, I know.
Time of one full-time revolution, yes, is T equal 1 over F. Because,
Wouldn't you just divide velocity by the time? You how far it is?
yes, you can do that. Okay, let me just explain like this. Okay, so let's say you are here, yes. Good. Okay. So if you want to complete one rotation, what is going to be your displacement? What is going to be the distance traveled?
0.
No. The 2 pi r. Okay, the length, you see, you just move from here and then come back exactly the same location, yes? What is the length that you have traveled? 2 pi r, yes? 2 pi r. Okay, the perimeter of the circle. Because it should be multiplied by radius.
Well, you said displacement, right?
No, the distance traveled.
I thought you said displacement.
The distance traveled, yes?
That's, R is what's the circle, how long?
Okay, so, you know, it takes t second, yes? We call it period, to go from here to here, yes? Okay. We already have the velocity, good. Let me just calculate the L. L is how much? 2 pi 0.5, yes? Okay. And what is the velocity? L over T, yes? Okay. So right now, what is the L? 2 pi 0.5. What is the time? 1.43. Okay, so if you calculate this, you will get still the same velocity, yes?
Yeah. I don't know, us, we do 1G, which equals frequency with your revolution, or whatever.
Yeah, revolution, okay. Okay, can you calculate this? Okay, so 2.19, yes? 2.19, yes, okay. What was the velocity that we calculated? 2.2, yes, okay, which is going to be almost 2.2, yes. This is right, okay, so. But I don't know how you want to calculate the number of revolution, okay, if. 2.2, yes, divided by 2 pi, what is the radius? 0.5, okay. So by calculating this, okay, what you will get for frequency is gonna be 0.7 rev per second. Okay, so this question, okay, you know, you and me were thinking the same thing. Okay, how many revolution? Okay, so it's telling that it is a 0.7 revolution in 1 second happening.
How did we do part of the here when we did this?
That's gonna be the same thing. That,
2.19 is not the same as 0.7. That's
no, we rounded. We rounded, you know. Yeah.
still not 0.7.
Frequency is a period.
Couldn't you calculate frequency by just doing 1 divided by the time?
Time. But again, we calculate the time, okay, and then you can plug it here. It's gonna be the frequency. It's gonna be the same answer.
Oh, and then
Good.
if you don't have T, then you could just calculate it. this way.
Exact.
Okay, so that's a calculation. So it
Yes.
is a lot easier with T
With
than
T.
you don't have T.
Exact.
We did, and that's why we took out the right.
Yeah, that's the velocity, which we need velocity.
But we didn't need. Why are we finding it?
And then
We had it.
I think that was the
Okay.
question.
So part B, is asking to find the frequency. Good. Frequency is the number of revolution per second. How many revolution is happening per second? 0.7 revolution. It means that it's not completing the entire circle, yes? It is a 0.7 of the, let's say 70% of the circle. Make sense?
Then you would put 1 over.
Can you put frequency in hertz as well?
Hmm?
Can you put frequency in hertz
Yeah.
as well?
So
Divided by.
So it means that if you start here, okay, this is the half, yes? You will go until here, okay? It means that you will pass this point, okay? Point half, it's somewhere after this, yes? Because this is a 50% of the entire thing, okay?
So should I not even plus one or should I?
This one you do need to get the velocity.
Yeah.
Once you get that, you need to find the frequency, which you can either go with this formula. If you do go with this formula, you need to take the T and plug it in
Okay,
here.
so I can just erase this.
Incorrect. Yeah.
Good. So just frequency. Calculate the frequency, but I was thinking different thing, okay? So,
I know, that's what she was doing.
Okay.
Different on regular.
okay. So let's move on to the part. Any question?
I think we got it.
Now makes sense? Oh, just calculate the frequency. We have the velocity, yes? Okay, just plug into the formula and get the frequency. That's it. Okay, the important part, 90% of the part was calculating the velocity, okay?
Yeah.
Which we already did. So part C, you remember how the velocity was changing here? Velocity was changing like RG, yes? Okay, if you double the frequency, if you double the radius, what happened here? If the R changed to the 2R, yes? What happened to the minimum velocity? If I change this R to 2R, it's gonna be S square root of 2R times G, yes? Which is gonna be S square root of 2 times S square root of G, yes? What was the square root of RG? We already calculated the velocity. So the new V, yes, is gonna be S square root of 2 of the V minimum, yes?
Yeah.
Which is gonna be S square root of 2 times, what was that? 2.2, yes?
Correct.
2.2 meter per second.
Which is an increase,
How much?
3.13.
3.13 meter per second. So what happened if you double the radius, okay, the minimum velocity will be S square root of 2 times bigger than the V minimum, okay? Because why? Because the velocity is directly related to the S square root of R. Okay? If you make it 3 times, it's gonna be S square root of 3. If you make 4 times, it's gonna be double, yes? Okay. So let's move on to the new problem. One more problem, okay, and then we just go. Okay, so tell me, okay, 2 or 3? You want us to do 3? Let's do 3. Let's do 3. I did 2.
That's fine. That's what's harder.
Okay. So, can I have the sign-in sheet? Can you? Okay, let's read the problem together. Okay, so and see how we can solve this problem, or what steps we need to just to do part A, B, C, and D. At airport, luggage is unloaded from a plane into a 3 cars of a luggage carrier, as illustrated below. The acceleration of the carrier is 1.2 meter per second squared, and you can disregard the friction. The couplings between the cars have a negligible mass. Car 1 has a mass of 500 kilogram, car 2 350 kilogram, and car 3 400 kilogram. Yes? Draw a free body diagram for each of the cars. Find the F1, F2, F3, and how would each force in part B change if some luggage was moved from car 2 and placed in car 1? And how would each force in part B change, okay, if some luggage was moved from car 2 and placed in car 3? So there is no friction, yes? Okay. I'm gonna identify forces on the picture. So let me just change the color. Okay. So I call this M1, yes, M2 and M3. M1 is receiving external force. Good. What other forces is normal one, yes, and M1G. There is no friction. Good. But you see F2, what is this F2? Is a tension force, which because the block is attached to the cable, okay? The cable is massless. The cable is exerting force on the block, okay? The block exerts exactly the same force on the cable. Because the cable is massless, okay? So it is not object of interest, yes? What is the object of interest here is the M1, car 1. So how can I show this force? F2, good? No friction, I'm done. Move to the car 2. How many forces I have? Again, normal force, yes? Force of gravity, okay? You see, the car 2 is still attached to the same rope. So it means that this rope not only exerting force on car 1, but also exert the same force, okay, on car 2. Why same force? Because it's the same rope. I call it F2, yes?
I mean, the first one also have a 5 force.
Yes, that's why it's already drawn. Okay, so I said, okay, it's already drawn. That's why I didn't draw it. So, but M2 is still receiving one more tension force. Why? Because it's attached to this, yes, this one. Okay, so I call it F3. Am I done with all forces which is exerted on block 2? Yes. Why? Because there is no friction force. Friction. Car 3. How many forces that we have? Normal, force of gravity, yes, and F. So draw free body diagram for each one. Okay, so I'll draw what is the M1? Normal one. M1G. F1, yes. What is this? F. Yes, it is a tension, but she just put F2. Okay, that's why we just, it's a force. We call it tension, whatever. Good? You can call it T2 or F2. But we know that there is a force is being exerted. What is the M2? Normal weight, yes. F2 and F3. What is the last one? M3G, yes. And are we done? Again, in the exam, you may not have a step-by-step calculation, okay? She will say, okay, this is the system, the force is being exerted, okay? And this is your job to find the tension force between blocks. So this is your job to identify all forces which is exerted on each object of interest. We have three objects of interest, yes? Identify all forces and then draw free body diagram for each forces separate. So what was the acceleration of the entire system?
1.2 meters.
1.2 meter per 1.2 meter per second squared. It means that, what this means, it means that if you are exerting external force on F1, okay, M1, all these three, they are moving together with the same acceleration. So I can apply the Newton's second law for each one separately. Good. How can I write the Newton's second law for each one? I start with this one. Sigma F equal m1 time acceleration, yes?
Yeah.
In the y direction, they cancel each other. The net force in the y direction is 0. So it means that n1 is equal m1g. Good? But in the horizontal direction, okay, there is acceleration. How can I write these forces? Net force is going to be positive F1, yes, plus negative F2 equal m1 time acceleration. Good? So how about the second one? Net force equal m2 time acceleration. How should I write? Positive F2, yes, plus negative F3 equal to mass 2 time acceleration. What is the forces in the y direction? They cancel. So it means that N2 is equal M2G. What is the net force in the last one? Net force equal M3 time acceleration. Good. Which is going to be the only force which is exerted is going to be F3, yes? It's going to be mass 3 time acceleration. In the y-axis, N3 equal M3G. How many unknown value I have? F1, F2, F3. I wrote down all equation that I need. That's it. So which one of these equations helped me to find the first unknown value? The last one. Why? Because there is just one unknown variable, yes? I have acceleration, I have mass, and I can find the F3. So how? What was the M3? Do you remember what was the M3? Okay, M3 was 400. Okay, just let me just change the color. Okay, so 400, yes, multiplied by 1.2. How much I get? 480 newtons. So this is F3. So how can I, what is the next one? What is the next unknown value I can find here? F2, yes?
Or the second one, second part.
Yes, second. This is the F2, yes? Okay, so let me just. Okay, so I just write it here. I just use this one. What is the F2? F2 minus 480 equal, what is the mass of the second one?
350.
350 times 1.2, yes? So F2 is going to be how much? 480 plus 350 times 1.2, yes?
It's 420 plus 480. 900.
900? 900 Newton, yes? You see, I started from the last one, okay? I just go to the second one, find the second unknown, and then I can find the external force, yes? F1. How? Plug these two here. So F1 minus, what is the F2? 900 equal, what is the M1? 500, 1.2, good? So F1 will be 900 plus 500, 1.2. How much it will be? 15.
Got it like the total system weight and then divided each weight separately to get each of it.
You know, there are different ways to solve this problem, okay? Because we follow the step that she asked, okay?
Yeah.
Identify forces, draw free body diagram, and then
Yeah.
so I would be able to show you how we can find the F at the F1 at the beginning. Do you want me to tell you how we can find it? Add all masses together. So F2, F2, and F3, F3 are considered internal forces. They cancel each other, okay? If we assume the entire thing is one system, F2 and F3 are considered internal forces. They cancel each other. The only external force is exerted on the system is F1, okay? Let me just do this.
So instead of just doing F1, F2, and F3, you just make it all one.
Oh, one. Okay, I'm going to show you right now. You know, let's say this is the M1, yes? So M3. This is the M2, yes? This is the M1, okay? And there is a force is being exerted, F1. And we know that these are the forces are exerted, okay? F2, F2, yes? F3 and F3, good? Normal 1, M1G. Normal 1, normal 2, M2G, yes? Normal 3 and M3G. So we consider these as a one system, yes? So what does it mean? It means that I write the net force of the system time mass of the system, yes? Time acceleration of the system, yes? Okay. See how I write the mass of the system? What is the mass of the system? Yes, M1 plus M2 plus M3 time 1.2, yes? What is the M1 plus M2 plus M3? 1,250. Okay. Okay, net force. See? You see, there are forces inside, but you know, they are opposite direction. When you add, they cancel each other. They are forces, but when you add, they cancel each other because they are exerted, okay, in the opposite direction as a one system. And these two cancel each other. These two cancel each other. These two cancel each other. The only net force is left is F1. What was the F1? We can calculate, yes? F1 is going to be 1,250 times 1.2. When you calculate this, how much you will get? 1,500 Newton.
But you still have to use F1 to calculate for the other.
Yes, okay, yes. You still have to calculate the F1, okay, to calculate the F2. Now you can just say M1. Just pick M1. F1 minus F2 is going to be mass of the one time acceleration, okay? Because the acceleration is still same.
Could you write that out?
Yeah, yeah. You know, right now, okay, I come back to the one system again. Good. So this is going to be my system. Let me just change the color. Okay. This is my system, yes? What forces do you see in the system? M1, this is F1, this is F2, yes? I already find the F1. What is on now? F2, yes? Okay, how can I find the F2? Write the Newton's second law for M1. Sigma F equal M1 time acceleration. What is the net force? F1 minus F2 equal, what was the mass of the first one? 500? 500 times 1.2, yes? What was the F1? 1,500, yes? Okay, calculate the F2. F2 is going to be 1,500 minus 500 times 1 point.
How come it's F1 minus F2?
Because F1, yeah, F1 moving to the right,
F2 is going
F moving to the left. Okay, when we are adding forces, we need to add them with their sign. Positive shows the, you know, right shows the positive direction, left shows negative direction. Are we good with this problem? We find the A and B, okay, so what do you think? How would force will change if we move some weight from one car and put to another car?
Oh, thank you.
Yeah. You are taking some from car one, yes, from car two, and place in car one. Increases the force which is exerted on
So does it increase the force? It's force.
yes. Okay. F1 is not going to change, yes? Because F1 is the only external force, okay? What happened? Internal forces have to change, okay? Because you are picking one weight from one card and then putting on the other card. If we want to keep the acceleration is still 1.2 meters per second, we need to change these forces, okay?
Yeah, yeah.
Good. So if you removing weight mass from one and putting to the other one, the one who has a less mass, okay, will need less force. The one has a more mass need more force. Make sense? Because force and mass are directly related to each other.
So force to increase and force to decrease.
If you play if you take first mass from card 1 and put in card 2, okay, F1 is going to be same, okay, good, yes, because it's external, okay, but what happened, okay, F2 and F3 will be different, okay, good. Okay, so do you want to still do the problem or multiple choice?
Let's try a multiple choice just to see like.
Okay, good.
No, not yet. But that one.
Okay. First one. It is more difficult to start moving a heavy cartoon from rest than to keep pushing it with constant velocity because the normal force is greater when the cartoon is at rest. Coefficient mu s is less than mu k. Initially, the normal force is not perpendicular to the applied force. Coefficient mu k is less than mu s. D? Yes. You know, again, you have run, I think I was in your class, okay, when we were calculating the mu s and mu k, yes? Mu s and mu k, good. So definitely mu s is bigger than mu k. Is a constant number, okay, and is the quality of the object. Static coefficient friction, okay, and kinetic coefficient friction. Number 2 is always wrong because there is no mu s less than mu k. Always mu s bigger than mu k. Initial normal is not perpendicular. Normal, I just said last problem, is always perpendicular on the surface. Always.
Explain why.
Because the quality of the material, okay, it's help you to calculate the mu s and mu k. So mu s is the static coefficient friction, mu k is the kinetic coefficient friction. Good. A static coefficient friction is always bigger than the kinetic coefficient friction. Okay. Yes, okay. So it doesn't matter object is moving or not moving, as long as there is friction, okay, the mu s is always bigger than mu k.
That's the only point. Good acceleration.
Stop.
Hmm? So friction, okay, so we are not talking about the friction, okay. We are talking about the coefficient of friction. Yeah, friction, we have two form of friction. Static friction and kinetic friction. Let's say we have a block and you are exerting force, external force. The block is not moving. Do we have friction? Yes. What kind of friction? Static friction. Okay. There is friction, but this friction is static friction. And this static friction is changing from 0 to Fs maximum. But if it's start moving, there will be a kinetic friction. Okay? So if two identical masses are attached by a light string passing over a massless frictionless pulley, but at different height and then released, again, two identical masses are attached by a light string passing over a massless, frictionless pulley. Good, a pulley. One rope, okay, two objects. The lower will. I cannot hear.
Said the lower. They're the same way.
Okay. B, A, low. Okay, what do you think?
I think it's C.
See, why C? Can you explain why C?
It says two identical masses, so they're both the same weight.
Identical masses. You know, mass create a force of gravity, yes? One force of gravity is trying to pull to the right, one force of gravity is pulling to the left, yes?
But they're equal, right?
They are equal because they are identical, they will have same weight. When they are same weight, okay, so weight right and the weight which is what? Yes. There will be no movement. Good?
Has to be higher than the other.
Exactly. 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 Net force is going to be zero. Okay. So one force is trying to move it to the right, one force is trying to move it to the left. Yes. Okay. So when these, what are those forces? Force of gravity. Force of gravity is weight. Because both are identical, there will be exactly there will be equilibrium. Okay. So it's going to be C. Okay. So number 3. If you blow up a balloon, and then release it, the balloon will fly away. This is the illustration of the first law, second law, third law, or which one? Galileo's law of inertia. First, second, third.
Second.
Why second? Yeah, the system is being accelerated, okay, but it's telling that the reason that the balloon is moving, okay, good, because the balloon will be accelerated, good, okay, and there will be a balloon and air. Air is kind of exhaust force, yes, and these exhaust force, okay, exerting on the balloon, good, so the balloon, you know, the air exerting force on the balloon exerts force on the air. The third law. Action and reaction forces. Okay. Good.
What was the second law?
The second law is telling that, you know, you are exerting force on a system, the system will be accelerated. Okay. You are exerting force on a system and this system will be accelerated. Okay. So, and we can calculate the acceleration of this.
Said the third law is when one
The third,
upon another. Oh, okay.
perfect, you know, and then it doesn't mean that the second law is not applied here. It is applied here, okay, but it's telling that which one is more accurate. The reason that this balloon is moving is because of the interaction with air. The air or exhaust force caused the balloon to move.
So the third law is essentially just like two different
Object.
The second law is kind of like together.
Yes, we are considering them together. Okay, so and then okay, what are these two objects here? Balloon and air. That's it. Question C.
Right. You said I was wrong.
Yes, C. Okay, so what is number 4? a horizontal force accelerate box from rest across a horizontal surface. Friction is present at a constant rate. All conditions remain the same with the exception that horizontal force is doubled. What happens to the box's acceleration?
You know, everything except for C and D. Oh yeah, I agree. That's what I was saying too. Even C sounds better. I think it's double, or at least double. Yeah. Oh no, it's just less than now. With A or B. But it is an A.
Okay, what do you think? Analytic.
I I think it's A. I mean, it's A, but I think it should be B, but I don't know why, but it's A. Oh,
Yes.
you're saying don't worry about normal weight, so just worry about
As long as the mass is not changed. Yes. As long as the mass is not changed,
this stay the same. It's just
as long as the mass is not changed, the mass of the system is not changed. If you are doubling the force, you are doubling the acceleration. If you are doubling the acceleration, it means that you have doubled the force. Okay, that's why it's accelerating.
You can double those, but as long as you don't change the math.
Yes, because they are kind of directly related to each other. You know, that because we are riding, you know, see, net force is mass time acceleration.
So if, like, you change the math, it will change the other two.
Exactly. Okay. But here, if you keep the mass identical, mass same, constants remain unchanged. Okay. So if if you are changing the force, definitely the acceleration will change. If increase, acceleration increase. If decrease, acceleration decrease.
that's how.
Can you say louder? Can you repeat one more time? No, that's all right. Okay, so
Oh, because there's friction, so it'd be less than double.
do you want to draw the situation? Okay. You know, a horizontal box, a horizontal force accelerate box from the rest across horizontal surface. Friction is present. Okay. So it's telling that horizontal force, yes. Accelerate this from the rest, yes. Okay. And then there is a friction. What kind of friction? Fk. Good. And this will get acceleration. And the mass is m. All condition remain the same. You know, it means that the mass is the same mass, the ground is the same ground. Okay, friction is going to be the same friction. Okay, so with exception that the horizontal force right now, the mass is same mass, the friction is same friction. Yes, okay, but this force is double. What happened to the acceleration? Okay. You know, whenever you are trying to just think, you know, try to draw the situation, play with the Newton's second law, okay? So if I write this here, let me just go here first. Let me just go and write it here. Okay, what was that? This is M, this is force, yes? Let's say this is the friction force, yes? Okay, and I call this A1, scenario number 1. Scenario number 2, I would like to see what happened to the acceleration if I change mass, I keep the mass same, but I double the F, yes? And then the friction force is going to be exactly the same. Good? So what is the net force here? Net force equal mass time acceleration, yes?
Yeah.
F minus Fk equal to m time A1. What is this one? 2F minus Fk equal mass time acceleration A2. Good. Find the F from here, yes? Okay. So let me just okay, what is the Fk mu k time n, yes? What is the n? N is mg. Good. It's going to be mg equal m time acceleration. Good. What is the 2f here? 2f minus, again, mu k mg, yes, equal m time acceleration number 2. Good. Okay. So what was the f? Okay, solve the first one for f. F is going to be what? Mu k mg plus ma1. And can I plug this here? Yes or no? Yes, okay. It's going to be 2 times mu k mg plus ma1, yes, minus mu k mg equal ma2. Good? Yes or no? Cancel all m's. Yes? It's going to be 2 mu kj 2a1, yes, minus mu kj, good, equal a2. What happened here? Mu kg plus 2a1, yes, is going to be a 2 time acceleration plus something more, yes? Okay. You see that? A2 is 2 time of A1 plus mu kj.
And that's positive, right? Does that mean it's
Yes.
it's high?
Yes. Okay, so right now, which one is the right answer then? It's better, sometimes you feel, because there is a friction, okay, so it's not gonna, acceleration is not gonna be doubled, okay, so good, okay, so it's become more than double, okay, so
What if there wasn't any friction? To be exact.
force double, acceleration double. That's it. External force, double, acceleration double. Good. When the friction involved, okay, so it's gonna be more than. Just keep in mind, okay. But we just proved that. So it is 1:30, okay. So but we can wait. We can stay until 2. Okay, if you want, because or at least 20 minutes to 2, okay, because there will be another exam prep party, okay. So do you want me to do problem 3 or 4? 3? You're good with 3? 4? 4? Yeah, if you want, okay, send me an email to this email address. Okay, write it down. If you want to record that session, or B Bana, yes,
They want you to say, oh, okay. Yeah. Okay.
asta lcc.edu. Okay, send an email to this email address, okay? Okay, yeah, send me, okay, because it takes a couple of hours the video get ready, okay? I will try to send it the slideshow. It's in your D12, yes.
All right, thank you.
You're welcome. We do one more problem, okay, and then so do number 4, and then again I will be available in the learning common, you know, just in case if you have any question. Okay, so
Your exam prep tomorrow?
there will be no exam prep, I don't think.
I was at the tutor that was really going through this, and I didn't, okay, oh wait, I'm sorry, yeah.
Okay.
Of course, at least I'm like. So. This is for the policy. I honestly forgot what the tutor told me, and it's telling me that the month, but I think that's the important.
So are you ready for question number 4? Or you are still, I can wait, you know. Okay, so a sledge which weight 150 Newton is pulled up 28-degree slope at a constant speed by force of 100 Newton, yes? How can I draw this situation? It is completely up to you, okay? So I just say this is the sledge, yes? And is being pulled up, yes? By how much force? 100 Newton, okay, and the weight of this, okay, the weight FG is 150 Newton, yes? What is the angle? 28-degree. First is asking to draw the free body diagram. Okay, is there a friction here? Yes, okay, because it's telling find the kinetic friction coefficient between them. So, can you tell me, okay, how can I find the forces? You know, this is the external force. We go with the external force. How many other forces we have? Normal force. What is the direction of the normal force? Perpendicular to the surface. Perfect. Good. And what other forces we have? Wait, what is the direction? It's straight down. Okay, mg. Okay, the system is being pulled up to the top. Yes. Okay, do we have friction? Okay, what is the friction direction? Is always in the opposite direction of the motion. F K, yes? Why K? Because it's moving. Okay, yes.
Does mg equal 150 n?
Mg, yes. Mg is the force of gravity, yes. Yes, mg is 150 n. Great.
That's with the sign and everything with it, or?
No, we just 150. Mg is 150, that's it. We have the force is 150 is downward. Okay.
So wouldn't there also be an X?
Oh, there you go. Now, okay, so, here, always, let me just tell you like this, okay? We always need coordinate system. Okay, coordinate system to show the direction, yes? And you can place the coordinate system wherever you want. You can say here is x-axis, here is your y-axis, yes? But if I choose this x-axis and y-axis, okay, you see all forces are not exactly in the direction of the x or y, okay? Because here we have two forces, N and Fk are in the different direction, not in x direction, not in y direction. The only force which is in the y direction is mg, yes? So it's better to change the coordinate system or rotate the coordinate system. What I do, I'll just place the coordinate system here. X and y. Right now, n is in the y direction, yes? Fk in the opposite direction of the normal. So I have weight. It means that I need to find the one force component. Okay, what is that force? Is the weight. Good? So, okay, tell me. Let me just erase this for now. Okay, so this is a y, yes? This is a x, and this is y. Good? Okay, so tell me, I need to draw a free body diagram, yes? This is my x-axis, this is my y-axis. Tell me, what is the direction of the normal force? What is the direction of the external force? What is the direction of the friction force? Negative x, yes? What is the direction of the mg? Oh, there you go. Okay, I need here to find the component of the mg, okay? So, if this is 28, this is gonna be 28, yes? Okay, mg component here is gonna be 150, yes? Cosine 28, yes? And this is gonna be what? 150 sine 28. Good? So right now I have two forces, two new forces, which are component of the weight, okay? So what is the one? $150, yes? Cosine 28, yes? What is the other one? Good? What?
Oh, no, yeah.
Good. I just have these two. Okay, I just put them in the y direction and then x direction.
Yeah.
Yes.
Since for question B, it just asks us to write the Newton's second law equations for the sled, that would be satisfactory, right?
Yes. Okay. We are not there yet. Okay. We just draw the free body diagram. Okay. Part 2 is asking write the Newton's second law. Okay, I need to write the Newton's second law in how many direction? X and Y. So X direction is gonna be sigma F equal mass time acceleration, yes? In the Y direction is gonna be sigma F equal mass time acceleration. Good? Separate. So tell me, what are the forces in the X direction? Okay, friction and force, yes, okay. How should I write it? Positive or negative? Positive plus minus Fk, yes, plus sine equal mass time acceleration in x-axis, yes, acceleration in y-axis. You remember the question says that it move with the constant speed. It move with the constant speed through the x. Okay, if it's move with the constant speed through the x, it means that the acceleration is
0.
so acceleration is 0. This is gonna be 0. Good. Okay, write down the y component. So what is the net force in the y component? There you go. Positive n plus negative 150 cosine 28 equal, in the y-axis we don't have any motion, yes? See here, the block doesn't move in the y direction, okay? No motion. So what is the acceleration is? 0. Okay, how many equation I have? I have 2 equation. Okay, I'll just write it down. 100 minus, instead of Fk, I can write mu k time n, yes? It's gonna be mu k time n, good, minus 150 sine 28 equal to 0. From the second one, what I can get from the second one? N is gonna be equal positive 150 cosine 28. Here, this is, this was part B. And we are now in part C, okay? Calculating the mu k. Simplifying all equation, okay, and calculating the mu k. And I can plug it here, yes? It's gonna be 100 minus mu k time 150 cosine 28 minus 150 sine 28 equals 0, yes? Okay, how many variable I have? Just one variable, is the mu k. Okay, solve for mu k. Okay, if I solve for mu k, it's gonna be 100 minus 150 sine 28 divided by 150 cosine 28 degree equal to mu k. Go ahead and solve this number.
Or I mean the cosine. I mean the sine, yeah. Good.
Yeah, it is negative. Okay, you see? No. I just keep this here, okay, and take this to other side, yes? It's become positive and then divide both sides by 150 cosine 20.
Why then you multiply the friction by n again?
No, because we got the n from the second equation here. You see this equation? N plus minus is going to be minus, yes? N minus 150 cosine 28 equal to 0. So n is going to be 150 cosine 28, yes? So that's why I picked this n and just plug it here. Okay. And then you got mu k, okay, so 100 minus 150 sine 28 divided by 150 cosine 28, okay, so Did you calculate this?
Yeah, 1, 2, 3.
0.23? 0.23, yes? And it makes sense because mu k it should be less than 1. Okay, we are done with this. Let me just stop. There you go. It is a 1 hour and 30-minute video.